Hello everyone, I am Dr. Rajesh and I am again with you with my new video lecture, and in this video lecture we will be taking up the problems based upon the article that we have driven in the last lecture. So the first problem is something like two forces acting at point are such that if one of them is reversed, the direction of the resultant is turned through a right angle. So, prove that the two forces must be equal in magnitude. Okay, let me first draw the figure. Say this is the force P, okay, and say this is force Q. Now read out, two forces acting at a point are such that, now these are the two forces acting at a point, one of them is reversed. Reverse means if this is in this particular direction, it will be reversed in this particular direction. Then resultant is turned, their resultant. So let us first mark their resultant. Okay. So let me complete the parallelogram. So this is also Q and this one, and the resultant goes like that. This is resultant R and this is also P. So once again, if two forces acting a point are such that if one of them is reversed, the direction of the resultant is turned through at a right angle. A direction means if we say this resultant is acting at an angle theta, okay, and these two forces are acting at an angle say alpha, okay. Now for this particular case I am going to write the formula of the direction of resultant R. So what is the formula? So let us write the formula. Formula is tan theta is equal to sine of the angle between them and the other force. Here the other force, the primary force is P, other force is Q. So here I will be writing Q, and here the primary force plus Q cos alpha. So this is for the first case, the case number 1. So now let us do whatever is given in the statement. The given in the statement is two forces are acting at a point are such that if one of them is reversed, let us say we reverse Q. Okay, what is the meaning of reversal? We are going to take the force of the same magnitude but in the opposite direction, opposite to Q. Let us say we reverse the Q. You will write in the language that we have reversed the Q. So we are going to reverse Q. So we are going to reverse Q. Say this is the reverse and of the same size. This is reverse Q. Okay, fine. So then what happens? Now see again, if one of them is reversed, I have reversed it Q2 in this direction Q. The direction of the resultant is turned. This is the direction of the resultant making angle theta. This is turned through a right angle. So turning will be in the anti-clockwise sense. So this resultant will turn and say it will turn, okay. So this is the resultant. It will remain the R If here it is r, the magnitude will once again be r. There is nowhere mentioned that magnitude is going to affect with that changes. Okay, so the resultant of the forces is still the same, despite the fact we have reversed the direction of the force q. But what has happened with the resultant, the thing that have happened with the resultant, that it has turned now with an angle of 90 degree. So what is this total angle now? This total angle now is nothing but 90 degree plus theta. So this is this angle. Fine. So let me write a tan theta formula for this second case. So for that you need the angle between these two forces. If you consider this as minus q, then you can take alpha. Otherwise the angle between q and p will be measured in the anti-clockwise sense. So in the anti-clockwise sense, this angle will be measured. So what shall I be doing to measure the angle? I will be marking it somewhere here. So this is the angle. Okay, what is that angle? If this angle is alpha, so this particular angle will be, this is 180, okay, and this is alpha. So this will be 180 plus alpha measured in the anti-clockwise sense. So this angle will be, you may write 180 plus alpha or pi plus alpha, whatever you want. In the degree it is 180, in the radian it is pi plus alpha. So it is up to you, whatever you want to write you can do it. So it is very simple. Now we have taken this direction here and this, and angle is measured in the anti-clockwise sense. So here I am going to write tan, the angle, the resultant, this r resultant is making with the force p is nothing but 90 plus theta. So I have no fear writing over here as 90 degree plus theta, and the force, this force is other force, r is making an angle 90 plus theta with p. So other force is q here. So this will be q sine of angle between them, it is 180 degree plus alpha divided by the primary force p, and this is q cos 180 degree plus alpha. Now use the, and you may name it as equation number 2. Okay, fine. So now next what I am going to do, I am going to use the quadrant, the whatever the positive and negative values of the sine and cosine ratios in the quadrants I am going to make use. So this will be cot theta and it will be of minus sine. Okay, it will be of minus sine. So it will be minus cot theta is equal to q, and it will be sine 180 plus alpha is nothing but sine alpha, and sine will be negative. Okay, fine, divided by p plus q cos 180 plus alpha is cos alpha, and in the third quadrant cos is negative. So I think it is fine. Cos q sine alpha p minus q cos alpha. So you may name it as equation number 3. So now we have to prove that forces must be equal in magnitude. Now we have a tan theta, here is cot theta. So cot theta is 1 by tan theta. So there is one possibility that we could multiply both these equation. In that case this and this will cancel it out. So I am going to, I am not going to leave this opportunity, and I am going to multiply them. Multiplying equations 1 and 3. Okay, so this will be tan theta into minus cot theta is equal to q sin alpha divided by p plus q cos alpha into minus q sin alpha divided by p minus q cos alpha. Fine. You know tan and cot will cancel it out. This implies that this is minus 1. This will be minus will be here q square sin square alpha divided by p square minus q square cos square alpha. This minus to minus will cancel it out. So now I am going to take this term over there. So this will make p square minus q square cos square alpha is equal to q square sin square alpha. So this will simply give p square is equal to q square sin square alpha plus q square cos square alpha. So I am going to take q square outside, sin square alpha plus cos square alpha. This implies that p square is equal to q square implies p is equal to q. So I think that is what we were required to prove. Two forces are must be equal in magnitude, both p and q. If they will be following this case, they must be equal in magnitude. So we have shown it. So now we will be taking the next problem, and next problem is given by, it is given by the resultant of two forces p and q trisect the angle between them. Trisect means to divide into 2:1. So one angle will be 1/3 and other will be 2 times of 1/3, 2/3. So let me draw this one, trisect. And one thing is mentioned over here, show that if p force is greater than q, so p force is greater than q, that is important thing that you must pay heed to, that this p is greater than q is important condition. We cannot ignore this particular condition. So whatever figure we are going to draw, we are going to take this condition into consideration, and based upon this condition one result will be used, that will be the orientation of the resultant, that the orientation of the resultant will depend upon this particular result, that p is greater than q. So dear students, please give attention to this particular condition, p greater than q, and draw your figure accordingly, because here it is clearly mentioned in the statement that p is greater than q. So now I am going to draw the figure. So let me draw the figure. This is force p. So let me make it somewhat straight. This is force p, make it somewhat larger, p, okay, and this is force q, smaller than p, it is must. So now complete the parallelogram. Okay, this is also force q, and this will be force p. Okay, fine. Now see over here, this is the resultant. Okay, you will clearly see if this is making an angle, this one so this angle is more, this angle is clearly more. So let us it trisect. Trisect means if like this angle, okay, trisect means dividing it into 3 parts, dividing it into 3 parts. This is 1 part, 1, 2 and 3. So if we trisect them, so we will be doing something like that. 1/3 portion will be here and 2/3 will be here. So if we take it as alpha, then trisecting will give alpha by 3 and other will be 2 alpha by 3. So to avoid the fraction, I am going to take the angle between P and Q as P and Q as 3 alpha. Okay, so let us take it as 3 alpha. So trisecting means one will be out of these two, one will be alpha and one another will be 2 alpha. So now to decide which one will be alpha, which one will be 2 alpha, we know that if the case, remember the case in which we have studied, if P is greater than Q, then resultant will be inclined, झुका होगा किसकी तरफ ज़्यादा, बड़े फोर्स की तरफ. बड़ा फोर्स कौन सा है यहाँ, P. So here P is the greater force, so this angle will be less, this angle will be more. So out of 2 alpha and alpha, which angle is less? Alpha is less. So I have no hesitation in saying that this angle will be alpha and this angle will be 2 alpha. So this will be 2 alpha and this will be alpha, this will be alpha. So now can we name the various points, corners? This is A, this is B, this is C, this is D, and this is resultant R. So I think this is very much clear to everyone. This figure is important, and in this figure this thing that P is greater than Q is important. This is the punch line or punch, this is the key point in the question. This if I say is the key point in the question, so it would, there would be no exaggeration, this is key point. Okay, let me write it is key point. So now before moving further, I will share once again with you what is sine law, and you have studied it in 10 plus 1 class, 10 plus 1 class. Okay, so what is that? Let us take any triangle. This is the triangle. Okay, and I am going to name it as A, B, C, and these are the angles. This angle is say alpha, say this is beta, this is gamma. Then what is the sine law? This side AB is proportional to sine of the angle opposite to this side, which is sine gamma. So let me write the sine law. Sine law will be AB sine of the angle opposite to this one is gamma. So gamma BC sine of the angle opposite to this BC is alpha. So this will be alpha, and this is AC sine of the angle opposite to AC. AC is this one, so opposite to this is beta. This is beta. So this ratio is always equal. This is called sine law. Now what I am going to do, I am going to make use of sine law in this particular case. For this we need a triangle. So you can take any triangle. I am going to take this triangle. Okay, this angle is known alpha. Okay, other two angles are not known. So what we'll do, this is 2 alpha, so this angle will be also 2 alpha. So I will be writing it as 2 alpha. Fine. Now we know that sum of the three angles of the triangles, this angle and this angle, will be 180 degree. It will be 180 degree. So what will be this angle then? It will be 180 minus alpha minus 2 alpha. So this will be 180 minus 3 alpha, or you can write it as in radian pi minus 3 alpha. So this angle will be pi minus 3 alpha. Now writing using sine law in triangle, mention the triangle in which you are going to use the sine law, and triangle is A B D. In triangle A B D, you have to clearly mention that which triangle you are going to use for the sine law. So now you are going to write the sides first, then you will write the sine of the angle opposite to that particular side. So I am going to write the side first. So this will be, first side is AB, another side is BD, next side is AD. So now let me write the angle opposite to AB. So opposite to AB is 2 alpha. So this will be sine 2 alpha. Fine. Now angle opposite to BD, what it will be? It will be alpha. So it will be sine of alpha. Now next angle opposite to AD is pi minus 3 alpha. So this will be sine pi minus 3 alpha. So I think I am clear in writing this thing. Now you see this side AB is representing the force P. So instead of AB I can write as P. So I am going to do this. I am going to write instead of AB I am going to write the, so firstly I am going to rub this one so that I could create some space for me to write the equation. Okay, so I have created the space. So instead of AB I could write P divided by sine 2 alpha, and BD, what is BD? BD is representing the force Q. So you will be leaving without wasting even a single second, you will write over here as Q, and it will be sine alpha. This is further equal to, and what is AD? AD is representing the resultant R. This is representing the resultant R. So I am going to write here as R, and this will be sine pi minus 3 alpha is sine 3 alpha. So firstly you have this equation, and you will name this equation as equation number 1. Okay, fine. Now take the first two ratios of this equation. So let us take the first two ratios. What it will give? It will be giving P sine 2 alpha is equal to Q sine alpha. P sine 2 alpha is 2 sine alpha cos alpha Q sine alpha. Sine alpha to sine alpha will cancel it out. This implies that cos alpha will go over here and Q will come down. So it will be cos alpha is equal to P by 2Q. This implies that alpha will be cos inverse P by 2Q. Okay, now see what we are required to determine. The angle between them. Angle between them means forces. This force P and Q. What is the angle between them? 3 alpha. We have determined alpha. So angle between the forces, if I write angle between the forces between the forces is equal to 3 alpha, and from number 2 it will be 3 cos inverse P by 2 Q. One thing was this which was required to prove, and other thing is resultant is P square minus Q square by Q. So we have taken the first two terms because it was containing sin alpha, so I have taken it with this one. Sin 2 alpha we know is 2 sin alpha cos alpha, so this sin alpha will again be taken with the third term. So now I am going to take the second and third term of equation number 1, and let us see we could find something out of it. So let us take the second and third term. Q sin alpha is equal to R sin 3 alpha. This implies that Q sin alpha is equal to R sin 3 alpha. You know that sin 3 alpha will be 3 sin alpha 4 sin cube alpha. This implies that Q sin alpha, we have to find the resultant, so this will be 3 sin alpha minus 4 sin cube alpha is equal to R. So this sin alpha here will come out and will cancel out with that one. This implies that Q 3 minus 4 sin square alpha. Okay, fine. But here we are required to determine only R in terms of P and Q. Alpha is not required in the final expression, so this needs to be removed. But how can it be removed? We have the value of cos alpha, but we don't have the value of sin alpha. But we know that sin square alpha can easily be converted into cos square alpha with the formula 1 minus cos square alpha. So we are going to exploit that particular formula, that is Q for 1 minus cos square alpha is equal to R. Fine. Why we have exploited that particular formula? Because we have the value of cos alpha, but here we are fixed in sin square alpha. How to remove that thing? You have to just convert sin square alpha into cos square alpha. So with that particular formula you have converted it successfully. So now what next you will be doing? You will be checking that what you will get with that particular thing. Okay, now using this particular value, cos alpha is equal to P by 2Q. So this implies that Q is equal to minus 1 plus 4 times cos square alpha is P by 2Q whole square is equal to R. This implies that Q minus 1 plus 4 P square by 4 Q square is equal to R. 4 to 4 will cancel it out, implies Q minus Q square plus P square divided by Q square is equal to R. Q to Q will cancel it out, implies R is equal to P square minus Q square by Q. So this is the value of the resultant. This is a Q. So this was required to prove. You will see that we are required to prove that it is P square minus Q square. This is a P square minus Q square. So we have proved both the cases. First is this one, this is proved. Second is we have to prove P square minus Q square by Q is the resultant. So that thing we have proved over here. This thing has been proved. So in today's lecture we have discussed two important problems, and this problem is very important from examination point of view. I am going to mark it as important from examination point of view. So in today's lecture we have studied two important problems, and in the next lecture we will be taking other problems based upon these formulae that we have studied in the last lecture. So if you have any query, you could drop me in the YouTube section, comment section, and I will be more than happy to resolve your queries. And I hope you will be able to understand this lecture. And with that, I conclude my lecture, and I hope that you will go through this lecture, and I will be able to clear all your doubts. So with that, I would like to say goodbye, take care, bye bye, see you, and this is Dr. Rajesh saying goodbye, take care, bye bye.